Today we are going to be solving some quadratic equations, and there's many ways to solve a quadratic equation. However, today we are going to solve by graphing, and the reason why we graph first is so that you can get a graphical representations of where these solutions really are. Well, in our case, in this first problem, if you look at the equation, we see something that's different. We don't see the y term. So typically, on the problems that we had when we were graphing before, they would have looked like this. They would have been y equals, and then they would have had the x squared minus 6x plus 9. But the difference here is now this equation is set equal to 0. And that's kind of telling us what we're trying to do. We're taking this y term, and we're setting it equal to 0. And so when we go ahead and do that, we're trying to find out where this line, or actually where this parabola, where this graph ends up crossing the x-axis. And why the x-axis? Because that's what we have when y is 0. Those x-intercepts are the value of y for those is 0 for those values, and that's what we're setting y equal to in this case. So we've got to graph this. So the first thing I do when I graph is I use this little equation, negative b over 2a. And so I'm taking the b term and taking its opposite. So it's the opposite of negative 6 over 2 times by a, which is 1 in this case. So the opposite of negative 6 is just 6. 6 over 2 makes 3. So what this means is the graph will end up going, or there's this axis of symmetry. And what that means is that the values that we come up with that are solutions to this equation will have an opposite value, opposite of this line that I just drew. So now we want to find out what the y component of this vertex is. We know this graph opens up, so it's going to look something like this. We just don't know how far down on the on this line we should end up going. So we go ahead and substitute the numbers in there. 3 squared minus 6 times by 3 plus 9. So remember I had talked about before a little rule with these first two terms here, the a term and the b term. Well, when we do this work, we should always, when we're trying to find the vertex, these first two terms should always be opposite in sign, and one's double the other. And so we have negative 9 plus 9 makes 0. So what we find out is that the solution is actually the vertex in this case, because the vertex is 3, 0. So we go over to 3 and then up to 0, and there it is. It's just that point. If you want to graph the rest of it, well, you could go up 9 spaces. Remember, if you just cover up these two terms, you set x squared equal to 0, you set x equal to 0, set x equal to 0, you're left with 9. So you know you have a point right here at 9, and then there's a point opposite that. And so it's 3 spaces over, so 3 spaces over, there's another point. If you use the parent graph, that gives you even more points. Parent graph works this way again. Y equals x squared. If you plug in a 1 or a negative 1 and you square it, you end up with 1. But when you use this method, you have to go from the vertex, not from the origin. So if you go over 1 to the right or to the left, you end up going up 1. If you go 2 spaces to the right or to the left, and you square that, you get 4. And so if we go over 2 spaces, again, left or right, up 4. So there's 2, 4. And so that gives you a better representation of what that graph ends up looking like. But the main thing we want from this graph is where it crosses the x-axis. And where does it cross? It crosses at 0, 3. So the solution is 3. And you can just write, you don't need to write the ordered pair to represent that. Just the number where it crosses the x-axis. So this is our solution set. Just have one number of 3. On the next one, x squared equals 4. Well, the first thing you're going to want to do is subtract the 4 from both sides. And so this way you've got the x squared minus 4 equals, and it really equals y, but what we do when we do 4 minus 4, we end up with 0. So that's what we're doing. We're setting y equal to 0. So this way we can find out what those x-intercepts are, where it crosses this x-axis. So we use that little formula. It goes negative b over 2a, but we don't see a b term. b is 0 then. See, the b term, remember it goes this way. It goes ax squared plus bx plus c. So we've got our c term as negative 4. A is just 1, but no b term, so we treat that as 0. over 2 times by 1 just makes 0. So 0 is x. Let's find out what the y component of that ordered pair would end up being. Well, 0 squared minus 4 would leave me with y at negative 4. So there's the point, 0, comma, negative 4. So we're going over 0, down 4 spaces, putting a dot, and then what we can do is we can use we can't use the y-intercept method because that is the y-intercept. So what we have to do is we have to go with the parent graph. And so let's do that. Y equals x squared. So what we're going to do is if we plug in a 1 and we square that number, or negative 1 for that matter, and you end up with a y component of 1. So what that means is from the vertex. Again, this parent graph only works from the vertex. So over 1 space, up 1 space. And if you square 2 or negative 2, you get the same value of 4. So from the vertex, over 2, up 4. And that's all we need. We just need to see where it crosses the x-axis. So our solution is those 2 points. So I'll just go ahead and bold those in maybe blue here to show you that it's this point here and this other point on this side. So we've got 2 and negative 2. So we have 2 solutions. So now you've seen a problem where you have 1 solution. We can have 2 solutions, but we could also have no solutions. So we'll see if we end up with one of those answers in this problem or not. So those are the different possibilities. A no solution would look something like this. It would be a line that is above the x-axis that just never does touch, or it could end up being below, but it would have to be opening down. So those would be no solution problems where it just does not cross the x-axis. Well, another set of directions may say find the roots. Well, the roots are the same things as the solutions. And the solutions are those x-intercepts. So that's what we're looking for, is just x-intercepts. So let's see if we can figure these ones out. We've got 2x squared plus 4x minus 6. When they ask for the roots, you're not going to see the equal sign. So what you can do is you can still set it equal to y. So y equals 2x squared plus 4x minus 6. If we were to graph it, we need to have those 2 components so we can be able to have ordered pairs, the 2 variables that is. And so we're going to figure out our axis of symmetry, negative b, so it's the opposite of 4 over 2 times a, which is 2. And when we do that work, negative 4 over 4 makes negative 1. So that's our x component. So if I go over to negative 1, there's a line right next to the y-axis in which I can find points that are opposite of that line that are on the graph. Well, let's find the y component of this vertex. So we just do 2 times by negative 1 squared plus 4 times by negative 1 and then minus 6. So we do some work there. This makes 2 because 1 squared or negative 1 squared is just 1. 1 times 2 is 2. Minus 4 minus 6. So negative 2 minus 6 makes negative 8. So there it is. The vertex is negative 1 comma negative 8. And so we go over 1 space and down 8, and we've got our first point right there. And so from there, we can use the parent graph if we want. And so the parent graph works this way. A little different. So let's go ahead and highlight that here. We've got y equals 2x squared. So what's different is we got this 2. So it's 2 times by a value that you pick for x. So let's go over 1 space to the right or to the left from the vertex. So you square 1, you get 1. You square negative 1, you get 1. Times by 2 gives us 2. So from the vertex, over 1, up 2 spaces. So if you go over 2 spaces to the right or to the left and you square that number, you get 4. 4 times by 2 gives us 8. So over 2, up 8 spaces. So there it is. Those are the 2 points where it crosses the x-axis. So if I wanted to draw the graph around those, you can see it a little bit better here. But all we're really looking for is where it crosses that x-axis. So our answer in this case is negative 3 and 1. And those are our 2 solutions. So we can put it in a solution set. Well, taking a look at the next one here, x squared minus 5x plus 10. So again, we're doing that negative b over 2a. Again, we're going to set this equal to y. So x equals the opposite of b, so it's minus negative 5 over 2 times by a, which is 1. So this makes a 5 halves. Now, whenever I've got a fraction, so 5 halves means 2.5. So we'd be 2.5 spaces over. So here's 3, so 2.5 would be like right down here. So this gives me an idea about where that line is of axis symmetry is. Kind of visualize now what that graph looks like, knowing that it opens up. Well, I'm going to end up using this 5 halves in for x. So 5 halves squared minus 5 times by 5 halves. And then I end up adding 10. So remember, as I said before, especially when we've got difficult numbers like this, you'll see that these two terms are opposite in sign and one is double the other. So this makes 25 fourths. And then on this other side, I end up with minus 25 halves. And so when I do the subtraction, because I do have to subtract, I'd have to come up with a common denominator. Now notice that you'd multiply this 25 halves by 2 to come up with the common denominator of 4. And see, that makes negative 50 over 4. Over here we have, again, this is a minus sign, so let me get rid of, since I put a negative sign, I can just make this a plus negative. This is 25 fourths. So notice, as I said before, one is double the other, and so we end up with negative 25 fourths. I've got to add it to 10, and so when I do this, I'm going to change 10 so it has a denominator of 4. So I'm going to multiply it by 4, so that makes 40 fourths. Do that subtraction, take that away, I end up with negative 15 over 4. So what I'm going to do is, I've got my ordered pair, and this is 5 halves, comma, negative 15 fourths. So if I go 5 halves, that's 2.5, 15 over 4, so 4 goes into 15 3 times, with 3 left over, so negative 3 and 3/4. So I'm down somewhere about right here. And then from there, I have an understanding about what it looks like. I'm going over one space. So again, I'm using that parent graph. It goes this way, y equals x squared. So if you go over 1 to the right or to the left from that vertex, we end up going up 1. So over 1, up 1. And then if I go over 2 spaces, I square that, I end up with 4. So over 2, up 4. So it puts me there and there. And so from there, I'm just drawing that graph. And it looks like we're going to end up having to approximate this where these solutions are. And so we're just approximating, figuring out about where these values are. And what I would say is, looks like it's going to be about here and about here. And so it's a little over 4.5, but we'll say it's pretty close to that. This is just an approximation here. So we'll say 4 1/2, that's one of them. And then this one looks like it's right in between 1 and 0, so I'd just say about a half. So the thing with graphs is it's kind of an approximation, especially in a problem like this where the numbers just didn't come out exactly even like the other 3 problems did. So we'll learn other methods to graph later on. Part 2 will have some projectile problems, some applied problems that deal with solving quadratics. So take a look at part 2.